Hello and welcome to Lars' Electric Endeavors. In this video we're going to install the STM32Cube software products on Ubuntu, on Linux. And this is Kubuntu 24.04. And after installing all the tools, we're going to make a simple project where we will blink an LED on this board. So what are these tools briefly? The CubeIDE is the Eclipse-based integrated development environment where you have, of course, the text editor to write the code, and you have the compiler, and you have a debugger, and you will be able to write code and make it run on the chip here. I will say that Eclipse is a bit old-fashioned today. Most developers, they don't really like it, and of course there is no AI assistance. But this platform does have a very feature-rich debugging environment where if you want to single-step the code or investigate the registers or the memory regions, it's still a very good choice to open up the IDE and do the debugging from there. The CubeMx is a tool where you have a graphical user interface where you can configure your peripherals and all the other settings on your STM controller. And after that, it will generate the boilerplate code basically with all the drivers, all the initialization done according to what you did in the user interface. So this tool is very useful for getting started, and it will also provide you with the CMSys, which is a standardized interface for microcontroller code. So I recommend definitely to use this tool to get started fast for these kind of chips. The kubeclt, that's a packet with command line tools. And in the future, in other videos, we're going to use the tool for programming. So we will be able to script programming these chips without having to use the Cube IDE. So let's get started with the installation here. The first step is that we will get the software. And as you see here, there are two choices here. And what I recommend to choose, at least what worked the best for me, was the Linux one, generic Linux, and not the Debian packet. And if you click here, you have to sign up on ST's website, and you have to accept some licenses. And then in the end, it will give you a file like this. Here we have it. And let's just extract it. I like extracting stuff like this on the desktop. I'm not sure if that's a good habit, but when it's on the desktop, it indicates to me that this is something I will be removing in the future. Now we can take a look here. So that's a script file. And I will immediately go into the terminal and take a look here. You can see there's a script we want to run, but it's not executable. So the change modifiers command with a +X will make it executable, and then we can run it. And this is, by the way, a virtual machine that I'm using for these videos. And the entire point is to show you how the installation looks from the beginning, from a Linux where it hasn't been installed before. So I'll just pause the video. No need to pause. Yeah. There's a lot of licenses. Okay, that must be that for the Cube IDE. And it wants you to pick a workspace. Why not? So here you have your first glimpse at Eclipse, perhaps. While it's thinking about the welcome screen, let's start with the CubeMx tool then. Again, you will click the Get Software, and also now you will have a choice between the. No, actually, there is no Debian packet choice here. There's only the Linux packet. And if you get that one, you will end up with this file here that I already downloaded. So let's extract the CubeMx packet. And what did that bring? That's a folder. What's in the folder? Again, I really prefer to have a look in the terminal first. This time we have something which is already executable. So let's do it. CubeMx. Sure. What happened over here? Yeah, empty workspace. The Eclipse-based IDEs, they have a concept called a workspace, which is not really your project, but a workspace can contain a number of projects. And you can kind of import them into the workspace, or you can create them in the workspace. What happened with the installer? It's here. No need to do that. So I believe we now have the MX tool. There. So this one also installed pretty painlessly. And it wants to use the wallet. Let's just set up some wallet here. And here now we can go to the board selector. I'll just briefly show you the point of this tool. That was strange. So you pick a board, and in this case we will pick the exact development kit we have here, which is called NUCLEO. This one is the F01RE. There we have it. And then I simply double click it. And yeah, sure. And here we have the graphical user interface I was talking about, where you have a visual representation of the chip. This is this exact chip. And you can basically have a look at all the I/O, and if you click this one, you can, for example, see what's going on here. What can you use this particular pin for? And by default, they already set up the UART, which will be connected to the serial port on the programmer. And I believe they connected some GPIO as well. I think we can see it here. So that's the UART I talked about. And you can see how you have the bull rate and settings available here in a visual way. You can configure timers. Here we have the GPIO. And by default, because we chose the NUCLEO board, exactly this board, we have by default already PA5, which is the LED2 green LED. And we are going to use that in a second when we want the LED to blink. It's called LED2. And here, by the way, we have the blue push button, I believe. And you can see how the LED is configured as an output, push-pull, and the button is configured as an input. Yeah, no pull up and pull down. I suppose they have a resistor on the board, so they don't rely on the pull up resistor inside the chip. Anyways, let's go to the project manager and say STM32 tests. And let's put it in. I like to make a folder called dev for development projects. So let's put it here. And here I want to use the CubeIDE for building. Okay. And now it's going to download all sorts of stuff. While it's doing that, let's install the kubeclt tool. Again, if you are in here, you click the Get Software. You face the option of choosing between the Linux version or the Debian. Again, the Linux one was the one I had the most luck with. And when you download that, you will end up with, where is it? This file. So let's extract it again on the desktop. Now we're done with this one, we're done with this one, we're done with this one. And we're kind of multitasking a bit here because at the same time we are downloading all sorts of stuff here in the CubeMx tool, accepting some more licenses. These ones we can also get rid of. It seems like the zip was extracted. So we extracted the kubeclt on the desktop. And now we got again an installable script. And we have the same phenomenon going on here. It's not ready to execute because I need to set the modifier on the CLT file this time. And let's start this installation. That's okay. So meanwhile, we managed to generate the source. I'll just close it here and close this guy if it wants to close. So now over in the CubeIDE here, now we are ready to import a project. Existing project, and we can pick it out from here, I believe. So the CubeMx tool generated all of these files according to the specifications. So here you have the project. And now we are, let's just put in the password here. And the kubeclt is installed. I'll show you later how to use this actually. Here we now have a project, and can we build it? That's the CMSys I talked about, and these are basically standardized. It's basically a standardized API for the, I believe, the ARM family of microcontrollers. This is a 32-bit ARM M0, which is the microcontroller core. Here we have the source, we have the main, and here you will see how in the and the structure generated by CubeMx, you have this rather ugly source tree with all these code begin, code end sections. That's the main function. And the point of all this stuff is that you're supposed to only put your code in between these markers. And then if you want to run the CubeMx one more time, it will actually be able to put in the generated code without modifying what you wrote between these markers here. So let's just see if we can compile this. Compiled just fine. Let's connect this one. Okay. Let's see if we can debug it. Yes, debugger. What do we choose here? It's an ST-Link. I found it. Apply. So this board, just a quick explainer here. This part of the board is our target with the chip that we're going to program and work with. This part is an integrated programmer called an ST-Link. And I suppose they intended that you might be able to actually break it off. You see there's a slot. So I suppose you can break it off and you will have a separate programming tool and a separate target to play with. And if you break it off, you will have to use a cable from the headers here to maybe some header here. Actually, I'm not sure. But I think most people, they just leave them intact because these kits are so cheap. Also, the programmer is not expensive, so it's much better to just keep it intact and use the programmer integrated like this. So that's the ST-Link, and we did a scan. If we have multiple connected, you will be able to see the same, a list of the different programmers here. I was not telling you the truth before. It's not an M0, it's an M4. The M4 is not the Apple M4 ARM. This is a term that they use in the ARM regime, and it means the microcontroller core number 4. There's also an M0. So let's do this. And now it wants to switch to the debug perspective, which is fine. And here we have the single stepping I talked about, where we can see memory, we can add monitors, we can look at breakpoints. Maybe I want to have a breakpoint here. Do you see any toggle breakpoint? And then you can also toggle the breakpoint by clicking here. So now maybe I want to run the code and have it stop here. That happened because we have a breakpoint. These are breakpoints. Expressions, registers. This is a very powerful debugging perspective to be true. Special function registers, what's going on inside the NVIC, and so on and so on. If you really want to do a deep dive into the internals of this chip, I think this is the best tool there is. Now we can just ask it to keep going, but nothing happens because we didn't do anything in the software. So why don't we stop the debugger? We are back in the C code here. So here, just give me a second. I'm back. So here I just wanted to prepare instead of wasting your time. So if we want to make this loop here, so basically when you have an embedded project, the CPU is always executing something. So there has to be an infinite loop somewhere, and that's the one we are looking at here. And I want it to run with a slight delay. So let's make a delay command here. And these are milliseconds. So if I put in 1000 here, we will wait 1000 milliseconds. And then to make the LED blink, we have to use the HAL GPIO. Control space is the invoking for the IntelliSense. And here you can see all sorts of functions are available to us. And I'm not going to use the toggle one, I'm going to use the right pin here. And LD2. This is the label we chose inside the CubeMx, the user label. And it's basically to help us name the resources. So here we have to pick the pin and the state. Let's just give it 1. And then let's make another delay here and then give it 0. So it should be 1 second on, 1 second off. Let's see if that works. And there you have it. That's the LED blinking. So why don't we make a little branch based on the user button? So the button was called GPIO. Sorry, it was called B1. There's a user level for that, a user label. So we can do a GPIO read pin B1. The GPIO port is B1, and the pin is, oops, is like that. And we can actually take a look at the macro here. It's GPIO-C and the pin is 13. And these defines were made by the CubeMx again, as I told you. So if we read the pin, and if it comes out with a truth value of 1, no, let's do it differently. Let's say that if we read the pin, we will make the delay much shorter. And the same here. So the point of this code is that if you push the button and this becomes true, then we will delay a lot less, so the LED will be blinking faster. Let's try that. So, okay, it's already blinking faster now. And when I push it, now it's blinking slower. So we kind of got it right, except for the fact that this one is true when you're not pushing the button. So I could do like this to invert the logic. So now it's blinking slowly, and it's fast now. Okay, why not? Why don't we just make a breakpoint here? While we are running, I just added a breakpoint. But that did not work. I think we need to... It's because I started it in the launch mode. I should have started it in the debug mode. So let's try that. Do we still have a breakpoint? Yes. Ah, this is the one I made before. Let's get rid of it. This is the one I just added. So we are ready now to run the code. Bam. We hit the breakpoint because I pushed the button. And then we can do all sorts of investigation, and we can, as I said before, we can look at registers and so on. So I will wrap up the video here. And this was a demonstration of how you would use the Cube tools to write some simple code and to compile it and debug it using the IDE. And the CubeMx tool was the tool we used for configuring the I/O, configuring all the peripherals on the chip based on a predefined board to make it as easy as possible. And yes, by the way, I didn't show the CubeCLT. Let me just quickly do that. Exit this one. So there is something called STM32CubeCLT command line tool. And in fact, for that tool to work, we actually need to restart our session in Linux. And it's good enough to do a log out and log in here. I logged out, I logged in. What now? STM32. So now we have it, programmer CLI. I think L does the list. So here you have a list of a lot of resources for some reason. But you will see here that the command line tool is actually able to see our ST-Link programmer. And it's also able to see the UART provided by the USB. So that means that we are ready now to use this command line tool to do programming, should we want to program this chip without using the CubeIDE, which will be the topic of the next video. But that's it for this time, and thank you for watching, and see you in the next video.